Hello friend, you just saw a simple robot manipulator drawing some mathematical curves. So I especially designed it for you. So with help of what I planned actually to teach you basics of robotics with the help of this simple robot manipulator. So in today's class, I will introduce you some basic terminology related to robot manipulator, and what I am going to teach you in next few classes, I will also discuss about those in brief. So first, let's talk about the robot manipulator itself, introductions. So it's now visible. Robot, can I see robot manipulator? Okay. As you can see, this is simplest kind of robot manipulator, and name of this robot manipulator is planar two-link manipulator. Why two-link manipulator? Because let's start understanding basic terminology related to robots. So this is your first introductory class about robots. So I will explain very slowly. So I named this robot as two-link robot manipulator, two-link planar robot manipulator. So what is the meaning of the two-link? Okay, the one word link came in picture. So link in the sense a simplest member in robot, okay, and the simplest member of this robot is one link, this link from this location to this location. So this is one link and this is two link, okay, and these links are joined together with a revolute joint. See, this is a revolute joint. So these are links, and this is joint 1, actually this is joint 2, this is joint 1, and this is joint 2. So that's why this is two link robot manipulator. And now the question is, why planar robot manipulator? Because you can see when I move it, so it can only move in a plane. Okay, you just see, in the sense this end effector can only go in a plane. So to draw a certain curve, what I did, I resemble a pen, okay, and you can see that this pen can be lift up and lift down just by using a servo motor, okay. The use of servo motor is not very important, just to lift this pen up and down only. So if you are beginner, so you can avoid this setup. You can just put the pen over here, okay. Then you can very easily you can use that. So in the sense, in simplest term, this is actuator 1, and with this actuator, this link 1 is attached with a revolute joint. Revolute joint in the sense, see, this is called revolute joint, in the sense this something can move only like this. So this knee is kind of revolute joint, because we can only move like this, okay. We are doing this, but this is different joint, okay. This is not at this joint, so this is kind of revolute joint. So this is revolute joint. This link 1 is connected with actuator, this stepper motor, technically called actuator. This actuator can be stepper motor, it can be servo motor, it can be even brushless DC motor also, okay. So in my design, for simplicity, I choose this servo motor. This stepper motor. So stepper motor attached with link 1 by using revolute joint. This link 1 attached with link 2 just by using revolute joint, and at the end of this link 2 I attached a pin. And also technically the end of the robot manipulators called end effector, okay. You can use any kind of end effector. If you are planning to hold something, so you can two finger gripper kind of end effector you can use. Otherwise you can use welding torch at the end effector. Even you can use laser cutter if you are planning to cut something. You can put some drills if you are planning to make hole over some surface, okay. You can use brushes if you are planning to paint something like that. Okay, not brush, actually is spray paint. So if you are using a spray paint process, so you can use a spray gun at the place of end effector. So these are the basic terminology, and now the question is which kind of topic I will cover in the complete course. So in very beginning, after this introduction section, I will teach you how to calculate inverse kinematics of the robot. Okay, again new term, inverse kinematics. So inverse kinematics in the sense, as I told you, that this is planar robot. So maybe this is going to be little difficult, not for you if you are beginner. Not even, actually I am designing this course not even for engineers and science background students. I am planning to design this course for layman, even normal people also. They can understand actually what is robotics, what is robot manipulators. So that's why I will use very simple term. Okay, and if you will ask me to make video in Hindi, then I am ready to do that. Okay, but what I found, most of the audience are engineers or student from science background. If I will found that someone is interested from non-science background, or he or she is not engineer and is still willing to learn robotics, then definitely I will make this video in Hindi also. Okay, but if you are not interested, if you are just watching YouTube video just for fun, then it's good to go in English. Okay, so I was telling that after this introduction section, I will, in my first class, I will cover inverse kinematics. So inverse kinematics in the sense, if any point is given in, if any point given in the two-dimensional space, suppose that this is the point, so is it visible? Okay, suppose that this is a point, actually this curve is made from many points. So you can see some zigzag lines, because this is going from this point to this point. So this curve is collection of many points. So how you can denote a point in XY plane? You can just denote the, is there can you find pen for me? Yes, okay. So like, if this is X and this is pretty difficult, this is Y. Okay, so if this is 0 point, okay, and suppose that somewhere here there is 1 point, so you just first go along X up to this location. You can measure this distance X, then move towards Y. So this is point, this is coordinate of XY. So even this simple curves is collection of many points. So for each individual point, suppose that this is point, so for this there is 2 point X and Y, for this there is 2 point X and Y, like that. So in the sense, any curves, any plot, anything in two-dimensional space, you can denote just by using X and Y point clusters. Okay, clusters in the collections, array is the proper word. So by using X, Y array, you can plot any curve in two-dimensional space. So I think this is going to be little difficult, but after your response of this video, I will try to teach in very simple words. But this is terminology related to robotics, so that's why I am using these words. So space in the sense, this is two-dimensional space. Now this is actually task space. Okay, this curve is in task space. What is my task? My task, actually not my task of this robot is to draw a simple curve in two-dimensional space. So the collection of points XY is in task space, and this is joint space. See, joint 1 and joint 2. For each point, see, suppose that this is point number 1. Okay, you can see for this particular point there is a special configuration of robot, in the sense this joint can be only a single theta. Okay, and for this joint 2 there is only a single angle theta 2. By moving joint 1 and joint 2, that particular angle theta 1 and theta 2, it will precisely go at point 1. Now for point 2, again you can see again when I am going for point 2, again joint 1 and joint 2 is moving for a precise point angle theta 1 and theta 2, and that is different from first set of theta 1 and theta 2. So different sets of theta 1 and theta 2 corresponding to each individual point xy, point coordinate xy in two-dimensional space, is called inverse kinematics. In the sense you are mapping this xy by using a mathematical relation. By using some mathematical relations, you are solving inverse kinematics, and you are getting these points, joint angle theta 1 and theta 2. This all phenomena called inverse kinematics. It's totally maths. It's not science. Okay, it's totally simple trigonometrical identities and relations. By using just trigonometrical identities and relations, you can solve inverse kinematics of this simple robot. Okay, so actually why I am planning to teach this complete course, because most of my student in different places, they ask, sir, what is the importance of sine theta, cos theta? Why you are teaching me all these mathematical steps? So by using this robot manipulator, and later few more videos, I am planning to design few more videos related to vibrations and all. So in those videos I will tell what is the real importance of mathematics in daily life. Nowadays in many industries, in manufacturing and production, and even in medical industry, at many places we are using such kind of robot manipulation. So that's why I am saying that in daily life we are using such kind of mathematics and science in our daily lives. Okay, so again after inverse kinematics, in next class, in the sense in second class, I will cover design process of this complete robot just by using CAD software. And in the same video I will cover the wiring of the complete robot. As you can see, I am using Arduino Dio microcontroller to operate this robot. All the mathematics I am solving this Arduino Dio, and to drive these stepper motors I am using two stepper motor drivers. So how to how to connect all these wires in these instruments, in these electronic elements, I will cover in second class. In third class I will use same mathematics what we developed in MATLAB. I will simulate and I will show you how you can draw different patterns in the simulation screen. Okay, that save your time. Before working on real world prototype and products, I will suggest you first simulate that thing, then it save your time and money also. Because if something is bad, suppose that anyhow you designed in bad manner and it's going in this and it's striking, okay, for a certain point. Suppose that anyhow you gave a point somewhere here, okay, and this robot is going somewhere here, so it's striking over here. So just by using simulation you can predict, okay, it's going there, so avoid that. So like that. So I will cover simulation in third class, and in fourth class I will give you some idea how to code this complete robot in Arduino IDE. Okay, I will explain everything in very clear and detail. Even after fourth class, if you are still ready to learn something new, then I can cover on your demand, okay, because that is going to be little complex. But still, if you are willing to learn, and I found some relevant comment in the comment box, so I will cover dynamics also. In the sense, dynamics in the sense, what I told you for kinematics in the sense, for given x y, don't, this is okay. Now they can understand. So for kinematics in the sense, for given xy point, what should be the angle theta 1 and theta 2, and respectively, like also position, sorry, this is position, this is also true for velocity and acceleration. Okay, but dynamics cover how much force we should apply over the joints, not force, sorry, torque, how much torque I should apply over the joints to track a given trajectory. Okay, suppose that this is trajectory, to track this trajectory, so how much torque I should apply over this joint 1 and joint 2. This is called dynamics. Okay, also dynamics help us to design control lights, going little bit difficult, but if you are still willing to learn after 5th class, if you are still willing to learn something more, so I will use those dynamic model to simulate control law for these kind of robot. Okay, after 5th class, some simple PID like control. So after PID controller, I will also try to cover some modern controller called computed torque controller, that is totally depend on that is dynamics based controller. So what we modeled in the dynamics section, we will use same model to design a control law, and hopefully this will cover all complete understanding for the robotics. But few students asked me to cover some little glimpse of the artificial intelligence in robotics. So I will also try to cover neural network based training algorithms, time series training algorithms to train inverse kinematic. Instead of mathematical model, I will use those algorithm to train our inverse kinematics model for the simple two-link manipulators. And thank you for attending this video lecture series carefully, and I hope you will join me again for next class. Thank you.